A dress-sewn Nyato timber column with standard grade at 19% of moisture content is 4 meter in height. The column is restrained at both ends in position but not in direction. Determine appropriate size of rectangular cross-section column so that the axial long-term column is more than 25 kN. Check the column is adequate to resist long-term axial load of 12 kN and bending moment of 0.8 kN about its x-axis. Let's check for the solution. The geometrical properties, column length is 4 meter. The column is restrained or pinned at both ends. So according to table 9 Malaysian standard, the coefficient is 1. Therefore, our effective length is 4 meter. We try to use 100 times 150 mm cross section for the timber. This is nominal size where the manufacturer put a label on the timber. The actual size is always a little bit smaller. So if we refer to table B4 Malaysian standard, for B minimum and H minimum for this nominal size is 90 and 140 mm respectively. From here, we can calculate our cross-sectional area, second moment of area at IXX and IYY direction. For radius of gradation, we use IYY with the formula B divided to power root of 12, we get 26. For section modulus, the formula is BD to the power of 6, we get 294,000 millimeter to the power of 3. We check the slenderness ratio by L effective divided by IYY, we get 153.85. And because the design not include the wind effect, so this value should less than 180. For the grade stresses for Nyato timber, we can refer to table 2 Malaysian standard 544 to get these properties. Then we list out all the factors related to the timber design, which is K1, this is for the long term, K2 for the load sharing, since there is no load sharing, so K2 is equal to 1. For the rectangular section, K5 is 1. For the depth factor less than 300 mm, the K6 is 1. We have to find the value of K8. There are two ways to get K8. I'll show you both methods. The first one using table 10. By using the ratio of elastic modulus to grade compressive stress, we get 763.16. So the value is between 700 to 800. For lambda value of 153.85, it is in the range of 140 to 160. By conducting interpolation, we can get K8 is 0.178. The second way is using the method of equation obtained from Appendix D, Malaysian Standard. So this is the equation. We key in all the values. We will get K8 equal to 1777, which is approximately or similar to the first method. So we solve the question A, where we have to determine the appropriate size of rectangular cross section so that the axial long-term load of the column is more than 25 kilonewton. We first calculate the permissible compressive stress is equal to grade compressive stress parallel to grain times with factor K1, K2 and K8. So we get 2.03 Newton per millimeter square. By rearrange the formula of stress equal to P over A, we can get the capacity of our column is 25.58. Therefore, the size of 100 times 150 mm is satisfactory. For question B, check that the column is adequate to resist long-term axial load of 12 kN and bending moment of 0.8 kN about its x-axis. So our loading is from the axial load 12 kN and applied moment 0.8 kN. We calculate the applied compressive stress equal to P over A. So P is 12 kilonewton. We convert to Newton 12,000 divided by, this is the cross-sectional area. We get the applied compressive stress 0.95 Newton per millimeter square. For permissible compressive stress, we have to multiply grade compressive stress with modification factor K1, K2 and K8. So the answer is 2.03 Newton per millimeter square. Since our permissible compressive stress more than applied compressive stress, that means that our compressive is satisfactory. Now we calculate the applied bending stress using M over Z. We get 2.72 Newton per millimeter square. For permissible bending stress, the equation is grade bending stress times with modification factor K1, K2, K5 and K6. We get 12.3 Newton per millimeter square. Since our permissible bending stress more than applied bending stress means bending stress satisfactory. Now we check that this equation or interaction is satisfactory, considering bending and compression of the column is less or equal to 1. We calculated this applied bending and permissible bending as well as applied compression and permissible compression previously. So we just key in all the values. The only value that we need to find is Euler critical stress. So the formula is pi to the power of 2 times with the E minimum divided by lambda to the power of 2. We get 1.15 Newton per millimeter square. So we solve this equation and we get 0.75, which is less than 1. It means that this equation or interaction is satisfactory. Therefore, the size of 100 times 150 mm timber is satisfactory.